everyone. So the question that we are going to consider now, same. So the question goes like, if t is equal to 1 over 1 plus 1 over 1 plus 2 plus 1 over 1 plus 2 plus 3 plus 1 over 1 plus 2 plus 3 plus 4. So basically the numbers are being increased and goes up until 1 plus 2 plus 3 plus till 2060. So it just has increased. If that's what t is, if t is the sum of all of these sequential terms which have a specific pattern with themselves, like the following those specific pattern, the question is asking what is the value of 2017 times t. So that's the question is about. So how we can actually approach it and how we can actually do it is really straightforward if you observe specific thing. So how the pattern is actually evolved, how the terms are actually progressing. If you try to see that pattern, it's basically 1 over 1 plus 2 plus till n is the nth term. What I mean by that, when you want to find out the first term, how do you write it? 1 over 1. When you want to find out the second term, 1 over 1 plus 2. So if it is second, you write 1 plus 2. If it is the third term, you write 1 over 1 plus 2 plus 3. So you get add numbers up until 3. So if it is an nth term, that means it's like a generalizing thing. It should be, or it would be 1 plus 2 plus going to n. That's how it's gonna be. That's the case. If you can write it like this, you can actually see something further as well. What I mean by seeing further, it's 1 plus 2 plus till n. That means it's basically, you can write it as n times n plus 1 divided by 2. Because the sum of those numbers. So you can write is equal to 1 over n times n plus 1 divided by 2. So now what you can do, you can simplify it further by multiplying up, down, denominator and numerator by 2, and you get 2 over n times n plus 1. For a specific term, you can write it like that. So what I mean by that, let's assume this term, which is the third term. So the third term is basically 1 over 1 plus 2 plus 3, and it would be the same as 2 over 3 times 4. That's what I mean by that. Is it true? Yeah, try to simplify. We end up with 1 over 6, and we simplify this, you end up with 1 over 6. It is indeed true. And why we are writing it like this? Because for a specific reason. We'll come to it in a minute. So we can write it like this. Now we can further observe. We can write it like 2 times 1 over n times n plus 1 as well. So you can write it like for here 2 times 1 over 3 plus 4, which is indeed true. But the advantage of writing the whole expression like this in a form of this, where it's like 1 over a specific value times 1 addition to that specific value, is you have an ability to write it in a different way. Means the technique is called as telescopic sums. Basically the idea goes like this: if you have a value like this 1 over 2 times 3, you can actually write it like 1 over 2 minus 1 over 3. If you have something like 1 over 3 times 4, you can actually write it like 1 over 3 minus 1 over 4. What's going on here? Let's see. If it's 1 over 4 times 5, you can write it like 1 over 4 minus 1 over 5. Try to simplify it, would be 1 over 6. Try to simplify this. Basically, you have to multiply this by 3, multiply this by 2, basically, so that denominators will be equal. But in the process, what happens is you subtract a number from a number which is 1 lesser than that, so you inevitably end up with 1. So basically, that mechanism ensures you can actually write an expression like this as a difference between two components like this. So you can actually write it like this. That's the conclusion. 1 over 3 times 4, you can actually write it like 1 over 3 minus 1 over 4. And that's a really good aspect of these kind of problems, because that's the point, that's the pivotal point that you're going to use to really extrapolate or really to really go further in this problem. So what we can do now using this piece of information, coming back here, we know each of the term could be written as 2 times 1 over n times n plus 1. That means all those terms you can write as 2 times first term 1 over 1 times 2. The second term 2 times 1 over 2 times 3. The third term 2 times 3 times 4. And it goes on up until the last point, which is 2 times 1 over 2016 times 2017. Now what we can do, we can take 2 as common, and we get 1 over 1 times 2 plus 1 over 2 times 3 goes to 1 over 2016 times 2017. Then what we can do, 2 times it's 1 over 1 times 2. Just as we have observed here, if it is 1 over 2 times 3, we can write 1 over 2 minus 1 over 3. If it is like this, we can write 1 over 3 minus 1 over 4. If it is like this, we can write 1 over 4 minus 1 over 5. We can write for this 1 minus half plus half minus 1 over 3, then 1 over 3 minus 1 over 4. It goes on, and here it will be 1 over 2016 minus 1 over 2017. And then you can cut these things off. Why you can cut these things off? Pay careful attention. You're basically subtracting one thing, then in the other term you are just again adding it. You're subtracting, you're adding, you're subtracting, you're adding. So you can just simply cancel all those things out. But you cannot actually cancel the last term, so it just remains. So you can cancel except that term and the first term. So you end up with 2 times 1 minus 1 over 2017. So that is 2 times 2016 over 2017. So that's the kind of an answer or simplified value for this whole expression of t. But do we have to find that? Not really, because they are asking 2017 times t. So we have to, if this is t, we need 2017 t's. So we have to multiply it by 2017 times 2 times 2016 or 2017. So we can cancel the 2017 off, and we end up with 4032. And that would be the answer for this question as well.